Hey everybody, good afternoon. Today we're going to be connecting the 7-segment display to the PIC on the breadboard and then testing it out a little bit just to make sure we did everything right. So I've got on the screen what you're going to need today, and that's your, common cathode 7-segment display, 7 jumper wires and 2 1K resistors. So today we're going to connect everything up using port B. Last time we put our LED for the blinking program on port A. This time we're going to be using a different set, and we're going to go through the setup for that and everything later on. But let's get started, and first things first, let's take a look at our schematic, our pinout, and let's find where our port B registers, or our port B pins are, So just like last time where our A port, or port A, was on RA, this time it's going to be RB. Just to simplify everything, I'm going to be using only port B pins that are on the right side of the chip in this picture, but on the board it's going to be the top. So let's take a look at those, and those pins are listed here. So it looks like we've got port B 15, 14, 13, 11, 10, and then 9, 8, and 7. And remember that even though this picture, pin 28 starts on the top, pin 28 is on the bottom here, so actually RB7 is this second pin up from the bottom. So if we take a look at, scoot this stuff up, take a look at our PIC here, it looks like those ports, those pins are going to be, skip the bottom one, it's going to be RB7 here on the second pin, RB8, RB9, skip 2, RB10, RB11. Here's the 3.3 volt USB pin, we're going to skip that. Then it is RB13, RB14, and RB15. We're going to be using all those, well, 7 of those pins. So to do that, let's get going. First things first, I put these the jumpers that connect my power and ground rail right next to the chip, but for the sake of this video, just so everything's easier to see, I'm going to slide those over to the end. So we'll start with ground, then we'll go power. Just to get these out of the way, next thing I'm going to drop is the 7-segment display, just somewhere out here. Make sure that you're bridging, that it's, well, I don't even know if you could connect it any other way, but make sure you're bridging the top half pins over this line from the bottom half, just so they're isolated. Okay, got that bad boy in, and next we need to take a look at our schematic for that part. I've got that here. Okay, so here is the schematic for a common cathode 7-segment display. If you take a look at the right, you can see that all of the LEDs that compose this 7-segment display, they have their anodes going out to individual pins. So on the bottom we've got pins 1 through 5, which correspond to the E segment, which is, where is it, right here on the left, and 2 is going to be the D segment, which is right here, and so on. This circuit diagram is going to become very important later on as we write our code, or as we write our driver for this. But for right now, just follow along with what I do on the board, and we'll get to all that later. But one thing, make sure you notice is on a diode has orientation. So if you hook it up backwards, things aren't going to work correctly. So you have to make sure you go in the direction that the diode allows current to flow. So current can go from the anode through to the cathode, and all of our diodes that compose the display have common cathode. And what that means is they all share the same ground path. So the first thing we're going to do is connect up that ground path, and you can see that it's pins 3 and 8 on the 7-segment display. So for us, as current limiting resistors, we're going to be using 2 kilo ohms, and to do that we're going to use 2 1K resistors. So we're going to go to pin 3 on that guy, which, since there's 5 pins on the top and bottom, it's the, let me get this down so you guys can see. Maybe. There we go. That looks a little better. So that'd be 1, 2, 3. It's this middle row. So I'm going to go just from from that to any other node, I'm going to start in the middle. And then from that new node out here, I'm going to go from there to ground. Okay. So that's basically, I just put a 2 kilo ohm resistor from their cathode, since they all share the same cathode, to the ground. And what that does is, as my voltage is applied to their anodes to turn on each segment, then current's going to flow through that resistor through 2 kilo ohms and into the ground. Why 2 kilo ohms? Well, I actually don't have the data sheet for this part, so I don't know how much current those LEDs can take. But if you remember, our PIC Kit 3 can only handle 30 milliamps of current total. So I wanted to make sure that if I'm turning 7 things on at 3 volts, that I don't have a total current that's going to be over that 30 milliamps. So if each one's obviously 3 volts divided by 2K and then times by 7, that's going to be less than 30. So we'll be all right. Next, we're going to be needing to connect all of our port B pins up to each of the pins on the 7-segment display. So we're going to be using our jumper cables. And hopefully I can get this all to make it easy for you. I think I'm going to go board only. Hang on a second. There we go. Okay. So how I'm going to do this is the pins that are furthest away on this PIC, they're going to go to the closest ones to it over here, just to keep everything nice and just make sure the orientation stays the same. So these first 3 pins down here. Oh, another thing worth noting is if you take a look, there's 5 pins on the top and bottom, and the middle pin on each goes to ground. So that leaves us with 8 pins, even though it's only 7 segments. One of those pins controls the data or the decimal point. We're not going to be using that today, so we're just going to leave that disconnected. And if you look at the chart, that is the letter C, which is over here, which corresponds to pin 4. So that's going to be the one right next. Oh wait, sorry, that's the decimal point, which is pin 5. My bad. Right here. So yeah, so the 5th pin on this side of the 7-segment display we're going to leave disconnected. Okay, so here we go. First I'm going to hook up these right 3, and so if you remember, we're going to skip the bottom one, and then it's going to be, yeah, can you guys see that? Yeah, okay. So I'm going to start here, and I'm going to go to pin 1 down here. Hopefully you can see what I did there. Okay. And the one next to that, it's going to go to the next furthest one. And RB7 is going to go to pin number 4 down here. Hopefully you can see I skipped that center pin because that's another path to ground. And then I skipped the last pin, which is pin 5, which is that decimal point. Okay. Get those wires out of the way. Alright. Now I'm just going to go in order, continuing on from there. So that'd be RB7, 8, 9. So here's 10 is next to that capacitor. And that's going to go, for me, I'm going to put it on the furthest pin away. There we go. 10. RB11 is going to go in the next one. Oh man, what a lovely angle I was giving you guys, huh? Okay, 12. We're going to skip that center pin and go right next to it, like so. Hope you guys can see that. And then out here, this is our last one, and that goes to this first pin over here. Alright. So this is what it ended up looking like. Again, we've got our 2K coming from this middle pin to ground, and then they just go in successive order skipping the middle pin and the last pin on the bottom. Alright. So let me... Oh boy, let's go MPLab X. And I didn't write a program for this, so I'm going to be kind of winging it a little bit. Yeah, you know what? Let's just use LED blink. I think that'll work just fine. We're going to close this project. So yeah, just open up that main.c that we wrote before, which, ooh, I forgot how much I hacked this up last video. Okay, I'm going to go ahead and delete all this. And you know what? I'm just going to leave it inverting that RA1 pin just to get a nice blink on that LED so we can see it doing something. Okay, if you remember, when we set up our LED, we had to initialize the port A pins. We had to use the tris A register to declare what's a digital input and a digital output. So we need to do the same thing. So we're going to do tris B bits. Oh, interesting. Okay, you know what? I'm going to cheat. I'm going to load a project I already did, if I can remember which one it was. I think it was this one. And I was wrong, dead wrong. Okay. Maybe this guy. Apparently not that guy. I don't think it was that one. Could be though. Yeah, this is it. Okay. I'm gonna cheat. We're gonna do we're gonna use this statement. Control C. And we're gonna go back to our original main and we're gonna copy that in there. So for you guys, we're gonna do tris B equals 0x807F. And if you watched the last video, you should know that I'm setting certain pins in that register using hexadecimal notation. Oh, I loved how I misspelled hexadecimal like in all my notes. Don't worry about it. So what this statement's going to do is it's going to set all those register pins. Let me get the schematic up, or the pin out. So it's going to set all of these pins over here. So it's setting RB7, RB8, RB9, RB10, 11, 13, and 14 to be digital outputs. And if you want to go through and verify that, you can. And the last thing I'm going to do here is I'm going to say lat B equals 0xFFFF. And that's going to set all my output pins high. I better put a comment here. Set our 7-segment display pins to be outputs. Okay, so that's going to set those to be outputs, and then it's going to turn all of them on. So let's save that guy. Oh, I need to plug in my PIC kit. Okay. And let's see if we can get that to just work. I'm going to turn this to... oh, do I have the board still? Yeah, I do. Okay, cool. So it's programming that up, and probably already you're seeing some blinking on that 7 segment. That's not our program. That's it programming itself. Okay, and now we've got our output. But something's wrong because only 4 of those 7 segments turned on. Now here's some troubleshooting you'd have to do. So what's one option? Maybe our 7 segment's broken. Well, we can test that really easy, where if I take one of these that is working and I touch it down here, so let's say I put it in this guy, take that one out and plug it in. Well, no, it's definitely not the 7 segment that's broken. So I'm going to put those back to where they were. Okay, so then what is wrong? The answer is found again in our data sheet, but it's a little bit hard to find if you don't know what you're looking for. And the answer is, if you'll notice, all of the pins that aren't working are on the bottom half of the 7 segment display, which correspond to pins RB7, RB8, and RB9. If you look through these, you're going to see at the very beginning that they are TDI, T-clock, and TDO. Those pins are all used for the J-tag. And that's something I'm not going to get into this video, but just know that since these pins are used for different things, the J-tag takes priority over our digital output, so we need to disable that in order for those pins to work normally. That statement is right here, and if you didn't know how to look this up, or if you didn't know what it was, I think I actually had to Google it. Once I determined from the data sheet that it was those pins were used for JTAG, in the forums they were saying how you needed to disable it. So this is the statement we're going to use. So I'm going to copy that, and we're going to paste it right up here after we initialize everything. So again here, this is disabling the JTAG. So pins RB7, RB8, and RB9 act normally. Okay, so we're going to save that and run it. Okay, and there we go. All of them are on, and that means we hooked it up correctly. So that's the end of this video. In the next video, we're going to get into writing a driver for our 7-segment display so that we can use it to display numbers and actually do something useful with it. So thanks for watching, and hopefully it all worked for you.